Chapter 4 is the single most important chapter in the first semester. Those of us that have been struggling a little bit with proofs, this is where proofs start to make sense for most students a little bit more. You get lots of practice at it, and they tend to be a little bit more straightforward. What we want to do in this chapter is be able to prove figures, maybe triangles, congruent to one another. So our definition of a congruent figure is a figure with all corresponding angles and all corresponding sides congruent. So we're going to be able to prove two shapes are congruent. So in this particular section, as long as I can use this definition of congruent figures by showing all corresponding sides are congruent and all corresponding angles are congruent, then I can show that the two figures are congruent. What we have here is what's called a congruent statement. And we can use that to go ahead and match up the congruent corresponding angles with the congruent corresponding sides. So if we look here, angle A goes with angle E. So these guys would be congruent. Angle B goes with angle F. So those two angles would be congruent. Angle C is congruent to angle G. 3 there. And then angle D is congruent to angle H. It's not enough just to show that the corresponding angles are congruent. We want to show that all the corresponding sides are in fact congruent as well. I can do the same thing and go ahead and use my congruent statement to go ahead and do that as well. What I'm going to do is just go over one at a time. So AB, that side, that segment, corresponds up here. What goes with AB? The first two letters on this congruent statement. So EF would be congruent to AB. Next, I'm going to go one letter over. Now side BC, I'm just going around clockwise here, is congruent to side FT. Notice these two shapes do not have the same orientation. They are, however, congruent. CD, congruent to GH. And we're gonna, once we get to the end, we're gonna overlap. So DA, so the last and the first, is congruent to HE, the last and the first on that. So there we go, two congruent figures, and using a congruent statement. So in the next one, we want to go ahead and use this congruent statement to show all of the congruent corresponding parts. So I'm going to go here. H goes with L. Angle H is congruent to angle L. Angle I is congruent to angle N. That's the second one in it. That's the second one in there. And there's two more corresponding angles. But let me start you on the corresponding sides. Corresponding sides, HI is congruent to LM. IJ is congruent to MN. See if you can find the other two corresponding angles and then the other two corresponding sides to this one. And then we'll pick that up. Wait. All right, moving forward. The other two congruent corresponding angles, angle J is congruent to angle N, I mean, And then angle K is congruent to angle O. And then I can go corresponding sides and go 1 over JK is congruent to NO. And then KH is congruent to OL. All right, so how can we use that idea of congruent corresponding figures or congruent figures? Go ahead and see if these triangles are congruent. So let's go ahead and see if we can take what we're given, what we know, just use our definition of congruent figures to prove that these are congruent. So first thing I know is that you're given that angle A is congruent to angle E, based on these lines right here. And angle B is congruent to angle D. We also know angle ACB is congruent to angle ECB. Because they are vertical angles. These guys are congruent in here. Right, whenever I see that X, I know those are congruent. I've shown all three angles are congruent, but that's not enough. We are also given AB is congruent to ED. We know that EC is congruent to AC. Because they both equal 6. BC is congruent to DC. Because they both equal 4. Since all corresponding sides and angles are congruent, the figures are congruent. So much of what we're going to be doing this chapter is being able to do proofs in proving triangles congruent without having to prove that all sides and all angles are congruent. We're going to look for shortcuts in proving triangles congruent. The triangles have special properties. They are rigid figures. I only need to show a few things are congruent in order to show that the two shapes are entirely congruent. All right. But moving on. Our third angle here. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. Let's take, for example, this. What if I know that I have a triangle, this is 70 degrees, and this is 60 degrees, and I have another triangle where I have this is 70 degrees, and this is 60 degrees. Yeah? So, do I know that these two angles are congruent? So I know that 70 is congruent to 70, I'm saying that 60 is congruent to 60. How do I know that these guys are going to be congruent?
Because A and B.
Well, they all have to equal to 180, right? So essentially this angle right here is just 180 minus 70 minus 60, right? So this is going to be 50 degrees. And then this angle has to be the same. So this would have to be 50 degrees as well. So of course they're congruent. So this can be extended further if we don't have any actual measures of the triangles. If we just know they're congruent, two angles are congruent, we know that third one has to be congruent as well. So let's do this proof real quick. And we'll do it in a two-column manner. Proving these two triangles congruent. AEB is congruent to DCB. Look at all the stuff we're given. Right? So let's go ahead and get started here. Statement of reason. So this chapter is the most heavy chapter in the proofs in the entire book. Sadly, we'll depart from proofs for a little bit because we're going through your section. We'll dabble in a little bit here and there in the second semester, but this is the main focus of this chapter. So I'm going to start with my givens. So my goal is to prove all corresponding sides are congruent and then all corresponding angles are congruent. So let's start and make sure we can do all the sides. We have AE is congruent to DC. EB is congruent to CB. And BA is congruent to BD. Jamie, what do you think? I'm also given that angle A is congruent to angle D. Now I'm going to try to prove that all the angles are congruent. I already have all the sides are congruent. So 3, angle ABE is congruent to angle EBC. There you go. So, Louis, how do I know that angle ABE is congruent to angle DBC?
Because all the lines agree.
ABE, DBC, what type of angles are these?
Vertical.
Vertical angles, right? Whenever we see that X in a figure, we're always going to use vertical angles. So we have vertical angles here. We put vertical angles. And then angle E is congruent to angle C. How do we know that? That's our third angle here. I showed that 2 of the corresponding angles in the 2 triangles are congruent, so the third one has to be congruent as well. And the last one, I've shown all corresponding sides are congruent. All corresponding angles are congruent. Therefore, the 2 triangles must be congruent. Triangle AEB is congruent to triangle DCB. By our definition of congruent figures. So, whenever I have two shapes, if I can show all sides are congruent and all angles are congruent, the two shapes must be.
What does that say? The
Definition of congruent figures. Here. All right. So, use that third angle theorem to just solve for the value of x in example 4. And I'll pass back your quizzes while you're doing that. We'll finish this one up. And then, take a test. So we're given that two angles in a triangle, so I can find the missing third angle, right? So I know this angle has to be 180 minus 55 and then minus 65. So we end up with 180 minus 120, or this is 60 degrees. So this has to be 60 degrees as well. Due to our third angle theorem, if those two are congruent, we know this third one has to be the same as well. So 2x plus 30 equals 60. Subtract 30 from both sides. 2x equals 30. Divide both sides by 2. X equals 15.